Hi, welcome back. In the last video we developed the law of sines, and now I just want to illustrate finding or using the law of sines to find unknown information in a triangle. And what we're going to do is we're going to use the law of sines together with some other information to solve this triangle. And solving a triangle just means finding everything we don't know. So the first thing I'm going to remember is that the three angles in any right triangle have to add up to 180. And so I'm just going to, I've already got B and C labeled, so I'm going to make this side be A, which means this guy is alpha and this guy is beta. Okay. So the fact that the three angles of a right triangle have to add up to 180 mean that 30 plus 50 plus gamma has to equal 180, which means that gamma has to equal 100 degrees. Okay, so I know that guy. So now to find the side lengths, since I know the three angles and I know one side, you always have to know at least one side. So you always have to know at least three pieces of information. And it's usually helpful if it's not just the three triangles, because you can scale your sides. So you always have to know at least one side in order to completely solve a triangle. So, or some other information. You can know a height, but you got to know something. All right, so let's talk about some law of sines. We know that the sine of alpha over A is equal to the sine of beta over B, and also equal to the sine of gamma over C. Well, I know both alpha and A, so that's helpful. So the sine of 50 degrees divided by 10 is equal to, and I know beta, the sine of 30 degrees divided by B. Oh, well, that works. Let's turn this equation upside down. So I've got 10 over sine 50 degrees equals B over sine 30 degrees. Multiply through by sine 30 degrees, so we get B equals 10 sine 30 degrees divided by sine 50 degrees. Now we know the sine of 30 degrees is 1/2. So this is really equal to 5 over sine 50, but sine 50 is not a special known unit circle value, so we're going to have a calculator answer regardless. Let's make sure I'm in degrees. And 10 sine 30, divided by sine 50 tells me that B is 6.527. Okay, now we can use the same basic approach to find C. Again, using the law of sines, we still know, and we can start out actually with the sides on top, since that's what we're going to be looking for. So let's just start out with the thing upside down. So 10 over sine of 50 degrees is equal to C, our unknown, over the sine of 100 degrees, which means that C is equal to 10 times the sine of 100 degrees divided by the sine of 50 degrees. And just because I can, I'm going to change, there we go. Okay, and C is 12.855. 12.586 we'll call it. Pay attention to how many decimal places my open math asks for. Okay, so that's the basics of the law of sines. Now, what good is this? Well, say we've got a situation like this. Two radar stations that are 20 miles apart both detect some unknown flying object located between them, and they measure the angle of elevation. And we solved this one before, or one like it. And what we did was we introduced a length here and a length here, and we found this elevation, right? But we had to go to a lot of work to do it. We don't have to go to so much work anymore. We still want that elevation. That's what we're after, is that h. But here's the thing. If I can find, I still need to find this and this, right? But I've got enough information to do that. And the law of sines is going to help me. And here's what we're going to do. We're going to find this angle right here. I'm going to label him gamma. Well, actually, yeah. So that makes this C. This will be alpha. This will be beta. So this side is A and this side is B. I know that gamma is 180 minus 15 plus 35, which makes gamma 130 degrees, if I can add today. Yes, 130. Okay. So, what? Well, let's just find, I only really need one of those angle sides. Let's find side B. So, side B divided by the sine of beta is equal to side C divided by the sine of gamma. Which means, so, filling in my numbers, B divided by the sine of 35 degrees is equal to 20 divided by the sine of 130 degrees, which means B equals 20 times the sine of 35 degrees divided by the sine of 130 degrees. So my side B, 20 sine 35 divided by sine 130. Make sure I'm in degrees. I am. Side B is 14.975 miles. And now I can find my altitude, because now I know that I can use just this little right triangle here to find that value h. This is bothering me. Sorry. There we go, that's better. Okay, so what do I know? Well, that's a right triangle, yes? So I know that the sine of 15 degrees is equal to the length of the side opposite divided by the hypotenuse, which means that h is b times the sine of 15 degrees. We now know b. So h is 14.975 times the sine of 15 degrees. So my unidentified flying object is 3.876 miles high. All right, so that's an introduction to the law of sines and the ways in which we can use the law of sines. I hope you can see how it can streamline some of our problem-solving activities. We'll come back in the next video and talk about a second technique that we can use when the law of sines doesn't quite work out for us.